Hello there, this is Kaundinya. In this video, I'm going to introduce our tool named RepoQuester that is intended to help developers in making decisions about which GitHub project to rely on. GitHub is an extensively large platform for open source collaboration. However, is it easy to find a good quality project? Let's look at the following. Chaitra, our software developer, wants to contribute to open source projects that have an active community around them, that are licensed, and that use continuous integration services. She also wanted to know the number of pull requests handled and the proportion of issues open to address. Dhruva and their team are building an open source cryptocurrency project. They would like to follow best practices during the project's development, such as writing test files, writing code comments, implementing continuous integration services, and so on. However, they are finding it difficult to assess whether their project has improved over time. Their goal is to keep track of different project dimensions that can improve their project usability and maintenance. Adding to these two scenarios, there can be several other cases developers are looking for in a project. The two scenarios I described have one common thing: the ability to get data on some aspects of an open source project. While this information could be mined by the person directly, it is not easy as it is time consuming. Automating this work could help them focus on identifying the relevant GitHub projects with less effort. And RepoQuester is aimed to serve those scenarios. We implemented RepoQuester by extending an existing tool named Reaper, which was built to assist developers in finding engineered software projects. But Reaper relies on the huge 100 GB GHTorrent database, and one has to download it in order to use Reaper. Hence, we re-engineered it to not depend on GHTorrent and to use it on local machine for any number of projects. In addition to this effort, we have added two new metrics to RepoQuester. Let's see RepoQuester in action. Users need to first download the repository. Following the steps as indicated in the README, users will be ready to use the tool. Let's try analyzing a few repositories. First step is to run an initializer script. Now it has created the necessary automated scripts to carry out the evaluation. By running the bash file run.sh, users will be able to get the metric scores for each project. After analyzing the projects, metric scores are stored in a local database file named repoquesterresults.db. Users can evaluate each project across 9 metrics. These are community, continuous integration, documentation, history, releases, and so on. Users can export the results into other formats like CSV and JSON and use the dataset for further analysis of projects. Let's relate how RepoQuester can be used to help developers. Recalling the case of Dhruva and their team, they can first analyze a set of projects with RepoQuester and get metric scores for each repository. Let us assume they want projects with good community and frequent release history. Now, they can filter projects that have at least 5 active contributors and projects with release score equal to 1 and sort them to the extent unit testing is done. Likewise, as per individual developer requirements, projects can be analyzed in multiple ways. Dhruva's team can even monitor projects' health over time by comparing the metric scores between different versions of the project and analyzing them with RepoQuester over a period of time. We evaluated our tool by measuring the performance of classifiers against Reaper. This ensures the authenticity of the scores produced by RepoQuester. The validation follows the same procedures as the previous work by Munaya et al. It was carried out in the context of a set of 187 repositories called the validation dataset, for which the ground truth classification was manually established. In this validation viewpoint, the performance of the random forest classifiers trained using the organization dataset is assessed. From an overall perspective, the random forest classifier trained on the organization dataset performs consistently better than the previous classifier, offering high recall and precision as opposed to the Reaper's classifier. It is interesting to see that adding new metrics to the classifier offered even better recall and precision. RepoQuester is independent of GHTorrent database and can be directly used on local machines requiring a fairly minimum setup. RepoQuester can be used to analyze a single or a set of repositories, and users can get the latest scores on a variety of metrics for the repositories at any time. Since our tool can work for any number of projects, it can be run on anyone's personal machine in a short period of time. We have verified the authenticity of the tool, and in the classifier's performance evaluation, we found that the new metrics appeared essential as it increased the performance of the classifier. RepoQuester is scalable, and adding new metrics is an easy and straightforward process.